Hi guys, this is the review for the review exam, question 3, the supply and demand question. We're going to start using now, so there's two parts of this. The first part is, the first sentence is the demand, which is a burger joint sold 250 quarter-pound burgers when they charged $3, but when they charged $4.50, they sold 100. So the way I like to attack this, now there's no graphically on this is pure algebra, is to set up what I call a price quantity table, PQ. Okay, the first, course, we're going to solve everything with price as the independent variable, because that's what the burger joint controls. He can put in the price and get out how much he sells. You can't force people to buy 250 quarter-pound burgers. You can charge what you want and see how many people buy it. So this burger joint charged $3 for the price and sold 250. They then changed the price. They raised it to $4.50 and they sold 100. So the demand function, D of P is going to equal, right? And we're solving part A here. D of P is going to be linear. It's going to be a linear function of price. So it's going to equal slope times P plus intercept. Now, to get that, the first thing I'm going to do is work out the slope. So I'm going to take Q2, in this case, I'll put that in here, Q2 minus Q1. This is exactly the same math we were just doing, divided by the independent variable, P2 minus P1. And we're going to plug in Q2 is 100, Q1 is 250. And we're going to divide that by 4.5 minus 3. Now this is always going to be a negative number. In this case, it's going to be negative 150 divided by negative, let me just put that in parentheses because it gets confused, negative 150 divided by 1.5. Which is equal to negative 100, which is the slope. Now, okay, so now I know the slope. Each of these quantities is the demands. So I'm going to pick the first one, and I'm going to say the demand when it's $3. So 250 is going to equal negative 100 times the price, $3, plus the intercept. Okay, so when it's $3, okay, and so this is going to be 250 is going to equal negative 300 plus the intercept. I'll add 300 to both sides. And by the way, the intercept is always positive in demand functions. So you should always have a negative slope, positive intercept, and 550 is the intercept. So my demand function, D of P, and I know the slope of the intercept, I know the function. Negative 100 times the price plus 550. So, check it I used 3,250, so let's check 4.5. See what happens when we put in negative 100 times 4.5 plus 550, and that gives me a demand, a quantity sold of 100. So this formula tells me for any price how many I can sell, and that's part A. So this guy is the answer to part A, demand function. Now let's do part B. Okay, part B is a little trickier. They can get 400 quarter pounders burgers from one meat packing plant at $1.50 a quarter pound, and from another they have 600 at $2 a quarter pound. Now they're not going to just go and buy 600 at the more expensive place. Any normal retailer will try to get the cheapest price they can. So they're definitely. So what I'm going to do is call a mixture problem. They're either going to buy 400 at 150, or they're going to buy from both suppliers, 400 and 600 at the 400 at 150 and the 600 at $2. So this is what we call a mixture problem. So we're going to have. So this is part B. What I'm going to do is create a table, but to create the mixture problem, I'm going to talk about the price, the quantity, but also, which is what we're going to build our supply function from, but we're also going to talk about how much we spend in total. So from the cheapest supplier, we're going to have a price of $1.50 a quarter pound, and the quantity we get is 400, and the total we spend is going to be $1.50 times 400 is $600. Now we're going to add to the 400. We're going to go to the next supplier and buy 600 from them. So I'm going to add the 600 quantity, and the total I'm going to spend on the 600 will be $2 times 600 is $1,200. So the quantity I'm going to buy from both suppliers is 600. 400 plus 600 is 1,000 quarter pounds. The amount I'm going to spend in total will be 600 plus 1,200 is $1,800. So if I buy 1,000 quarter pounds for $1,800, I'm going to have 1,800 divided by 1,000, or my average price I'm going to spend from going to both suppliers is 1.8. So I'm going to use this price quantity, 1.5, 400, and I'm going to use 1.8 as my other price, and 1,000. And then I'm going to do very similar math to what I did before. So this is going to be part B. I'm going to take S of P equals slope times the price. So how much can I buy plus the intercept? So if I spend $1.50, I can buy 400 quarter pounds. If I spend $1.80, I can buy 1,000, is what this table tells me. What's the general formula? And so I'm going to do exactly the same math, only I'm not going to write down it's exactly this formula over here, only I'm using these numbers. So I'm going to have 1,000 minus 400, Q2 minus Q1, divided by 1.8 minus 1.5. And that's going to give me a positive slope of 2,000. Now, it's positive because the more I'm willing to spend, the more suppliers I can get to give me stuff. So the more I can buy. So as I'm willing to spend higher and higher average prices, I can use more and more expensive suppliers and have access to greater and greater supplies. Now, we're going to then get the intercept, and once again, I know I'm going to use the first one because the numbers are relatively easy. The quantity will be 400, that's the supply, will equal the slope, which is 2,000, times the price, which is $1.50, plus intercept. 400 is 3,000. 1.5 times 2,000 is 3,000, plus intercept. So the slope is always positive. The intercept is sometimes negative, but there's no guarantee on that. Minus 3,000, minus 3,000. And that gives me negative 2,600 is the intercept. So the slope, so my formula is, for S of P, is 2,000 P minus 2,600. And I'll check that by putting $1.80 in. So if I get 1,000, I know I did right. And I do get 1,000, so it checks. So that's the answer to part B. Now part C, okay? So the question becomes, what happens? How do I get the equilibrium price? Now, equilibrium happens when the supply and the demand are exactly equal. So this is basically an intersection problem, right? Because I'm going to find out when these two guys, here's the demand function going down, here's the supply function going up. In this part, if you remember from the supply and demand lecture, okay, we have a lot more, but we can't sell them at this price point. So this is an excess. We have extra, a lot more stuff than we can sell at this price point. At this point is a shortage. So when there's a shortage, right, because this place we have the demand is very high, but we don't have enough stuff. So when there's a shortage, it pushes the price up. When there's an excess, people lower the price to get rid of what they have. And this is where we end up, equilibrium. So let's do equilibrium. Okay, so this is part C. We get the equilibrium price, and then we'll do part D, the equilibrium quantity. So what we do is we solve for the intersection just like we did in the previous problem. We set the two formulas equal to each other. So I'm going to take my demand formula and take my supply formula here and set them equal to each other. So D of P is going to equal S of P. The total being demanded is the total we supply. That's the price point where there's no excess, no shortage. Everything lines up. And now I'll replace them with their formulas. Negative 100p plus 550 equals 2000p minus 2600. Now, I'm going to add 100p to both sides. And that's going to cancel that out. It's going to give me 550 is equal to 2100p minus 2600. I'll add 2600 both sides to get all the regular numbers on the left side and the p part on the right side. So that's going to give me 3150 equals, and the numbers don't come out even because the realer the problem is, the less likely we are to get even numbers. And now I'm going to divide both sides by 2100. So I'll get 3150 divided by 2100 equals $1.50. And that is the equilibrium price. Now, let's find out the equilibrium quantity. So, when I plug $1.50 into both these formulas, I should get the same number. Let's see if that works. Well, negative 100 times 1.5 plus 550 is 400. Now it's on this table right here. So that would be, if it checks, this will be the equilibrium quantity, part D. And then we'll check it by plugging in the other 2,000 times $1.50 minus, I know it's going to check, 2,600 because I see that table there. And that's going to give me 400 as well. So that checks out. And that is the answer to question 3 of the review exam. And this whole thing up here is the review exam, which is also all in your lecture notes.